So, grade 8 natural science, term 2, we were solving questions on informal tests that we had about online classes, term 2. And then I solved the first 2 questions. I solved first 2 questions, and that's what I'm going to do, planning to do. I will do today is to solve question 3, 4, 5, if I can manage 6. That's what we are planning to do today. So let's read the question. What kind of question is this? This is what we call as matching. When we talk about science stream, okay, we talk about natural science, okay, I'm talking about natural science, physics, chemistry, biology, okay, well, the new name for biology is life sciences, okay, we use life sciences. For physics, chemistry, we use paper 1, paper 2. For physical sciences, we use different types of questions. So I'm also teaching you how to answer, react, how to find an answer from a question. Choose an item from column B matches a statement from column A. Write only the letter A to H next to the question number 3.1 to 3.6 in the answer book. And as you can see, it is 6 marks, 6 questions, 6 marks. So which means that each question for 1 mark, okay? So this is what we call matching questions. Matching questions, what we need to do, how do we answer this question, this type of questions is just to write down. Okay, can I just type it on the right-hand side of the screen? You just need to write 3.A for example A, 3.2, okay? That's what I understood from the instruction, okay? 3.3, C, and 3.4, D. Some people write down whole column A, whole column B, try to match it, okay? Write down everything. There is no need, okay? Because I also have the same question paper in front of me. It's easy to identify what's 3.1 and A, okay? So we answer this kind of questions like this from now, okay? Now everybody knows how to answer a question like this. And measure of amount of matter of an object, okay? That's what we discussed when we talk about density, okay? We said density depends on 2 quantities. One is volume, other one is mass. And the answer is supposed to be mass. 3.1 D mass. And when a liquid turns into gas, when we talk about phase change, okay? Liquid changes into gas, that's what we call as evaporation. Is there boiling here? Boiling, if there is boiling, we might use this, okay? But there is no boiling, only option is evaporation. Answer is G, 3.2 G. Energy that an object has because of its motion, okay? We said the objects are moving. When they move, they have something called kinetic energy, okay? Answer is H, 3.3 H, especially when we talk about the particles moving in a container, especially in gas phase, okay? I said the particles move faster, they have higher kinetic energy. I discussed this under the topic phase change. 3.4, when a solid turns into a liquid. This is under the phase change, solid turns into liquids. Let's check the options. Density, no. Cubic decimeter, no. Grams, no. Melts, yes, that's the answer, melting. 3.4 E. 3.5, amount of mass given in a given volume of matter. Amount of mass in a given volume of matter. So it's 2 quantities mentioned here, mass and volume. I'm sure 100% this one is what we call as density. I just told you about density. 3.6, the unit. 3.5 A. 3.6, the unit in which the volume usually measured, okay? Volume is about cubic decimeter, cubic centimeter, decimeter cube, decimeter centimeter cube, okay? So the answer is B, okay? So grams, when we look at grams, is the unit of mass, and condenses if something changes from gas into liquid. That's what we call condenses. It's a kind of physical change, phase change. And I hope that we are done with question 3. Let's move on to the question 4. As you can see on this diagram, question 4, it's about particle model of matter that we discussed. As you can see, A, the particles are close to each other in a solid shape, and same amount of particles in B, okay, what happens is that they are moving away from each other. They have more irregular shapes, When we look at the same particles, when we go to see there is more space, and then what happens is that they move away from each other. This is about states of matter. As you know that if it is more orderly, well, if the particles are more orderly patterned, okay, that's what we call as solids, okay, And if the particles move away from each other, that's what we call look at. Without answering the questions, okay? That's what I want to discuss. And then when we look at the last one, I think this is about gases, okay? So let's talk about this. Question 4. Study the diagram about states of matter and answer the following questions. Write down the name of the state matter shown in the diagram ABC. State of matter, solid, liquid, gas. So if it is more orderly design, if there's a solid structure, it's like this, as you see, it's solid. A, solid. B, liquid, okay? There is less order, okay? And then they are freely moving in C, that is gas. 4.2. Name the process when the diagram B particles turn into diagram A. B turns into A. It is a very easy question. That's what we call freezing. There is another name for this, solidifying. As I told you, I don't use solidifying. I like to use freezing. But if there is any answer similar to this, I gave full mark. Okay, these are just sample answers. I wrote it down and I scanned it and to be able to answer the questions online for you. Any similar answer, possible, logical answer, you receive full mark, okay? 4.3. And name the action must be taken for the process mentioned in question 4.2 to happen, okay? So to be able to freeze the substance, what we need to do, what action must I do, okay? I need to cool down. I need to remove energy from the system, okay? So anything you put it in a freezer, okay? Anything similar to this, you got received full marks, okay? Yes, I just told you that 4.2 can be solidification, okay? Solidification, it is correct, okay? That's correct. As I told you, anything similar, okay? Anything logical answer, okay? These are just sample answers, okay? You received full mark, okay? That's correct. 4.2 can be solidification. You received full mark for this. And 4.4, what does happen? Can I use my highlighter? What does happen to the forces that keeps particles together when the state change from A to B? A to B, what happens to the forces that keeps them together? It becomes weaker, okay? It becomes loose, okay? It becomes less, it decreases. Anything similar to this, you received, okay? My sample answer, this is just a sample answer, okay? And weaker. Why? Because as you can see that there is stronger forces at A, okay, stronger forces at A. If you have any questions, please put it on chat, okay? You can put it on chat and then I can try to answer your questions, okay? And if it moves to B, what happens? They are moving away from each other, okay? Anything similar to weaker, like gets weaker, it becomes less. Do not write particles move away from each other. I'm not asking about the position. I'm asking about the forces between them, okay? Yes, yes, yes. Soon I'll share your marks, okay? Like next week, you will receive your marks. Yes. If you have any questions, can you type it on chat, okay? Shortly, can you type it on chat? And then I can answer your questions when I'm done with this part, okay? So anything similar to becomes weaker, similar to, this is just a simple answer. Similar to becomes weaker, okay? You receive the full mark. 4.4, if you say for 4.4, it melts. It melts is the answer for something else, okay? I'm asking for what happens to the forces between the particles. And if you say it melts, it is physical change. I'm not asking you for physical change from A to B. I'm asking for when the physical change happens, okay? When the state change happens, what happens to the forces, okay? So you answered another question, okay? That's not 4.4. So that's why I'm asking you, you must be careful when you answer the question. So you got 0 marks for this if you say melts. 4.5, name the difference about the shape of matter in A and B. Shape of matter, as you can see, A is like solid shape, okay? Particles are close to each other, okay? They are hard, like how you can put it in this way, okay? Anything similar to the solid shape, you receive the full mark. And B, take the shape of the container, okay? They are away from each other. They are more irregular from A, okay? Anything similar to this, you receive the full mark, okay? My sample answer, this is just a sample answer, take the shape of the container, okay? And they slide over each other, that's also perfect, okay? So I told you different properties of about the liquid particles. I already discussed that. 4.6, in which diagram are particles moving fastest? Okay, which one is moving fastest? We said that the particles at A vibrating at fixed positions. Can I just move up? Vibrating at fixed positions, that's why they have solid shape. And they move a little bit faster at point A, B, and then when they move to C, they move very fast, fastest, okay? So the answer is supposed to be C, okay? There is no other option for this, only C. 4.7, the particles in diagram C are in a small box, okay? What would happen to them if you open the box in a closed room? The answer is supposed to be diffusion, diffuse into air, okay? But if you write anything similar to diffusion, like escape, move away from the box, spread around the atmosphere, spread around the air, okay? I try to give you full mark for this, okay? Anything similar answer, you got full mark. But actual answer is supposed to be diffusion, diffuse, okay? And then you know what is diffusion, okay? We already discussed this. Question 5. Density, mass, volume, and this is one of the easiest question. And half of the class, they struggled with this. I really don't understand, okay? And then, so we said that if there is a solid and liquid, if there's a solid and liquid, okay, like oil and the cork. So if the solid floats on the oil, okay, which means that oil has more density than, okay, cork. If you have two liquids like oil and water, which one at the bottom? It has more density, okay? That's what we need to use. That's all I'm going to use. I discussed this and gave you too many examples. Study the above diagram about density and answer the following question. Compare the densities of three liquids in the diagram. What are the three liquids? I don't have to have a colorful picture for it. It is easy to identify which one is liquid. Oil, water, and syrup, okay? Can you see this? So which one is at the bottom? It has more density. If you write something like this, syrup is more than water, is more than oil, and explain what you need to say. Explain. Let's check the answer. If you write anything similar to this, you got full mark, okay? I did it in this way. If you write more than, less than, I accepted that one. I just want to see this order, okay? This is short, simple answer. And explanation is 1 mark, and the lower density will float on other liquid. Higher density goes to the bottom. Which one is bottom? It has higher density, okay? Syrup has higher density than water. Anything similar to this, you receive full mark. And the compare the densities of three solids, okay? As you can see, similar to that one, okay? Similar to that one, you are going to compare the solids, cork, plastic block, and the grape, okay? As you can see, grape doesn't float on oil, doesn't float on water, it floats on syrup, okay? And then which means that it goes down through this way, okay? Which means it has higher density than others. When you look at the plastic block, it doesn't float in oil, but it floats on water. When you look at the cork, it floats on water. So which means that which one floats, it has lower density, which one sinks, it has higher density. So I can easily identify that grape has more density than plastic block, it has more density than cork. Or if you can put it in a mathematical way like this, can I just show you? This is the sample answer, sample, okay? Grape more than plastic block, more than cork, or you write it in your own words, perfect. Or for explanation, if you wrote something like this, lower density solids floats, higher density solids sinks, okay? Anything similar to this. Which one is bottom, higher density, which one is up, is lower density? I accepted all similar logical answers. 5.3, explain why then when the plastic block floats on water and grape sinks in water, okay? So we are talking about water. In water, grape sinks, plastic block floats. Okay, why? What is the reason for that? Can I just go down? Because, okay, we just need to write down. Grape has greater density than plastic block. Or anything similar, more density, higher density, you received full mark for this question. Okay, it was very easy. So next time when you answer a question, try to keep it simple. If you keep it simple, you get higher marks, as you can see. Okay, what you know, put it on the page. Question 6. Okay, I just want to finish this today. That's why I'm going a little bit faster. Sorry for that. Excuse me. Question 6. Okay, density, mass, and volume. Okay, it's about this. Okay, I told you it's about which topic. And study the case study given below and answer the following questions. And then I'm not going to read the case study. Okay. Okay, let's read the case study anyway, quickly. Can I read the case study quickly? Looks like we have time, and then I can answer the questions, etc. So let's read it. Case study, solid water is less dense than liquid water, okay? So which means that the ice has less density than, okay? Ice has less density than, water, okay? Water. So which means that when you buy cold water, for example, if you have water and then you want to make it cold, if you add ice, ice floats on liquid water, okay? That's what we are talking about the case study. Ice floats on liquid water. Is it normal? It is not normal, okay? Normally, when something, okay, any particle, substance, compound, okay, turns into solid, it is supposed to have higher density than liquid phase, okay? But for ice and the liquid water or H2O molecules, there's a special case. That's what we call hydrogen bonding. It's a miracle, and that makes it happen. And this means that ice, a solid, is less than water, a liquid. Yes, because it floats, as you can see on the picture. Can I just show you the picture? As you can see, the ice floats on water. Yes. Normally, the solid state of a substance is more dense than its liquid state. Yes, for any other substance like metals, salts, the solids, they have higher density than liquid. So which means that if you have the same substance in solid and liquid phase, and if you put them together in a container, what happens is that the solid substance is supposed to sink to the bottom. It's not going to float. Its particles are closely bound together and move around less. This is because energy has been removed from the liquid state. When water liquid cools down, its particles start moving closer together. However, as water starts to freeze, okay? So water freezing, why? Because you have winter conditions. The particles, okay, I'm going up. The particles move apart again very slightly. So you think of it like a crowd of people standing close together, pushing outwards slightly with their elbows. So what happens is that the volume increases. Same mass, volume increases. If it is same mass and the volume increases, if you remember from the volume relationship, what happens? The density decreases. Okay, it will have lower density. The people are still packed closely together, but they are pushing each other, others slightly apart. So when the water starts freezing, it floats again. This layer of ice keeps the water underneath, okay? So which means that when it starts frozen, those crystals, okay? Crystals of ice, okay, they go up. Why? Because it has lower density. They go up, float on the water. It's slightly warmer, so it does not freeze. What is that temperature? Anybody remembers that temperature? That's special. The highest density of H2O molecules, it is positive 4 degrees Celsius. I showed you a diagram for this, okay? So the H2O molecules, water molecules, they have the highest density at positive 4 degrees Celsius, and this one is liquid, not, okay? It is liquid, it is not solid phase. And it's slightly warmer, so it does not freeze. So what do you think would happen if ice froze from the bottom upwards in the lakes and rivers? So what happens is that, what will happen is that if it gets frozen from bottom, and then you have the aquatic life in water, like leaves, okay? So for example, plants, and we have the fish inside, fish, or not only fish, we have frogs and other animals also. And then if it starts freezing from bottom, and it's going to freeze again, and after a while you are going to see frozen bottom of the lake and river. On the top you are going to see a cold water, very cold water, and the animals inside. And if it is cold enough, what will happen? So it will get frozen totally. And then if it gets frozen totally, what happens? All the aquatic life, animals, plants, and other insects, they will die because of this getting frozen from bottom. But what happens is that it is a miracle, and then what happens is that it's a chemistry behind that says if ice is formed, liquid changes into ice, it goes up and it starts creating a frozen layer. It's like a lid, frozen layer on the top. It's like isolation. You know that isolation? It's very common in this time, okay? So isolates very cold weather outside to the inside of water, and then inside we have positive 4 degrees Celsius all the time, okay? Degrees Celsius, and then the water bottom will be warm, okay? Then outside, imagine that outside is negative 20 degrees Celsius, okay? So the water will be warm, and the animals like fish and the aquatic life can survive during the winter, okay? Not because they need water to be able to survive. Yes, they need water, but we don't want them to get frozen during the winter, and they cannot get alive. It's not possible at all during the summertime. 6.1. What happens to the density of substance when it starts freezing? Density, what happens? We just said that. It is here. Can I read it for you? Okay. The solid state of a substance is more dense than liquid states. Okay. So which means that, okay, when the substance gets solid, the density increases. Okay, that's given in the case study. Okay, you don't even need to know. If you read this carefully, you can easily identify. Okay, can I just ask you to can I just ask you to stand for a while? I'm just getting attendance now. Can I just get the attendance? Okay, looks like we are done. Can I close this? Okay. Okay, got the attendance. Let's go back to the class, okay, and then discuss this part. 6.2, explain why you're answering question 621. 6.1 supposed to, okay, there's a typing mistake here. 6.1, by using the particle model of matter, okay? By using the particle model of matter. Particle model of matter, so which means that what happens to the particles? I just gave you the example in the previous question. Here, I'm going to show you that. Question 4. S. Name the process, sorry, write down, okay. Yes, what does happen to the forces that keeps particles together when the state change from A to B, okay? So from A to B, B to A, what happens is that they're going to come close to each other, as you can see from this diagram. We already discussed in question 4.4 and the other questions in 4, okay? We answered this question. I'm asking the same question again. 6.2, when it changes from liquid to solid, okay? Liquid to solid, yes. So what happens is that it's freezing. That's not answered. Answer is here. Space occupied by particles decreases, okay? The particles, they come closer. And then what happens is that if you write also, this is just a simple answer. If you write, for example, the volume decreases, or if you write the forces get stronger, if you write particles comes closer to each other, anything similar to this, you got full mark. 6.3, why water is different from other substances according to its density? Why it is different from others according to its density? It is here. Okay, the ice solid, okay, is less dense water. If you write down this, you got full mark. Already, as you can see, out of 3 questions, 2 question answer is here. You don't need to know anything about the property of water when it changes from liquid to solid, solid to liquid. Okay, as you see, there is no need to know this. It's already here, the answer. Okay, and what is the sample answer that I wrote? Okay, when water freezes, density decrease. Okay, density decrease, or the statement in the text is 100% correct. 6.4. What is the benefit of property of water mentioned in 6313? Sorry, 63. It's 63 on living things in nature. Okay, explain briefly. So what happens is that when the water freezes, I just discussed that. It's mentioned also in the case study text. In nature, ice floats on water. When the ice floats on water, the aquatic life under ice can survive. Okay, can keep the water warm, can isolate the water. Okay, the animals and the plants, they don't get frozen. Anything similar to this, you got full mark. Don't write water is very important for, if you, half of the people they wrote this. Okay, I'm sorry, you didn't read the text. You didn't read the text and you just try to answer and finish the test questions. Okay, that's my feeling. Okay, okay, I explained this. I spent like at least 1 hour to explain this. Okay, and then you cannot answer the question like this question. Okay, as a natural science student, what we need to say: aquatic life can survive under the ice, because ice is going to float. It's going to start an isolation. And then why it is not? Because water is very important for aquatic life. Animals and plants, they cannot survive with water. Yes, but they also cannot survive when they are frozen. It's not possible generally. Okay, 6.5. What do you think would happen if ice froze or frozen from bottom up in the lakes and the rivers? Okay, when water freezes from bottom to up, and I just explained that the ice will sink to the bottom, and then the whole water will be frozen, and the aquatic life cannot survive during anything similar to this. Okay, so if you write anything similar to this, like whole lake and the river will start getting frozen and the aquatic life can die, okay, because they get frozen, what you can write for this: they cannot survive very cold temperatures. So they survive at what temperature? Positive 4 degrees Celsius. Okay, question 7. I just want to finish this and then we are done. So these are about the models of atom I discussed. Okay, it is somewhere at the beginning. Okay, if you check on Google Classroom, you are going to see that. I just want to answer this quickly and then we will be done. So what we need to do is, it's also matching. You just need to write 7.1e, 7.2a, 7.3c. That's how we answer the question. 7.1, his model of atom looked like a billiard ball. Okay, and then as you know that is John Dalton. 7.2, 7.1 is E. 7.2, the electrons are placed like raisin in a plum pudding model. We call it also plum pudding model. It looks like a pudding, and then there are stuff inside. Okay, like raisins inside. Okay, like I gave you example of cupcake and then raisins in the cupcake. So answer is Joseph Thomson. 7.2a. 7.3, he discovered that there is a small center in an atom like with a positive charge. Okay, 7.3 is Ernest Rutherford. Okay, Rutherford's gold foil experiment. I explained this. I didn't go into details. What we need to know that he discovered that there's a small center in atom that's called positive charge, and it's very small when we compare with the size of the actual size of the atom, where you can see the electrons are moving. And that's what we call as nucleus. Okay, he discovered the nucleus actually. Okay, he discovered the nucleus. 7.3 C. 7.4, he discovered that the electrons move in orbits around the nucleus. There is a name for this I'm going to discuss now. 7.4 is Niels Bohr. That's what we call Bohr model. It's like, okay, circular areas around the nucleus where you can see the electrons. That's what we call, I also call it as energy levels. That's what we call as Bohr model also. Niels Bohr, 7.4 F. 7.5, he discovered that there were some particles that did not have a charge. Okay, there are 3 subatomic particles: positively charged protons, negatively charged electrons. What was the other one? Zero charge neutrons. Okay, they are in the center. Okay, with protons, okay, in the nucleus. That's what we call 7.5. James Chadwick. It's around 1940s, if I'm not mistaken. So until 1930s, 40s, okay, we didn't know there was something called neutron. 7.6, the easiest one, okay, the first one, the oldest one, okay, oldest one. You remember this atomos example. He called as atoms as atomos, which means uncuttable, undivisible, okay. And then I gave you examples of this. I shared videos about this, okay. That's what we call this old name, Democritus, okay. Like this is BC time. And Antonio Lavoisier, okay, he was talking about the gas laws, okay, he was talking about the gas laws, okay. And Dmitry Mendeleev, he's the one, he discovered the periodic table of elements, okay. So these are not given in 7.1 to 7.6. So 7.6 is B. So that's how we answer these questions. I'm sure if one of you read this through, okay, the slides that I shared with you, you read it through before the test, you answered these questions in full because it was straight, it was clear, okay, it's easy to identify. There was no hard question here. And this is our periodic table, and I think we are done, okay.